Assalamualaikum warahmatullahi wabarakatuh, and hi. My name is Muhammad Akmal bin Abdul Halim, matrix number AA200308. I'm the group leader of my FYP project, final year project for the Diploma in Mechanical Engineering. So the title of our final year project is the E-Bus Simulation of Smart Sensing for Emergency Vehicles. So, firstly, I would like to thank both of the panel, Encik Muhammad Hanafi bin Asril and Technologist Muhammad Najib bin Jalal. Alright, here is the project organization chart. So, the coordinator is Encik Ghazali bin Qadis, my supervisor, Technologist Muhammad Abdul Hakim bin Muhammad, my co-supervisor, Dr. Nur Shahida binti Muhammad Shah, and Technologist Muhammad Irwan, and my group members, Ikhwan Hanif bin Muhammad Asri, and Muhammad Arif bin Rali. Alright, here is the example of the co-supervisor, surat lantikan of the co-supervisor. Alright, here's the work distribution throughout our final year project. Okay, so now what is our research background? So first and foremost, Malaysia has the fourth worst traffic congestion condition in the Asian countries. So thus the increase in the urban population and middle class contributed to the increase in the number of vehicles, traffic congestion and delays. Therefore, this will lead to the slow traffic and increase in the travel time. This is the major problem that we are facing. So it is imperative to improve the travel time and the efficiency of transportation, especially when it comes to emergency vehicles. So, the delay of the emergency vehicles due to traffic can increase the likelihood of the victim's death. So, preemption or a time division can be an aid for emergency vehicle to reach their intended destination in a significantly shorter amount of time. Thus, there is a need towards the application of smart sensing for the emergency vehicle. So, this project scope is focused on the simulation of the smart sensing for emergency vehicle using software. We have also proposed a new design for the E-Bus. Alright, so what are the objectives of this project? First and foremost, to prioritize information from real-time traffic monitoring to provide a faster emergency response. Secondly, to evaluate methods using case study for the efficiency in providing a faster emergency response and minimizing its delay on the traffic. And lastly, to develop a complete simulation of how the smart sensing for the emergency vehicle using software. Now, our project scope for this final year project of the E-Bus simulation of smart sensing for emergency vehicle is bound to the case at Pekan Bukit Pasir, Muar, Johor. So the traffic flow is heavy during the peak hours from 5 to 7 p.m. and the simulation will be conducted during these peak hours and the estimated cost is around 30 to 50. So what are the expected outcomes for us to conduct this project? There are three expected outcomes. First and foremost, to develop a proactive approach that uses a real-time traffic monitoring information to provide a faster emergency response. Secondly, to develop a sensing system based on the siren characteristic to detect the siren from emergency vehicles effectively and can respond promptly. And lastly, to conduct simulation on smart sensing, work on the approaching of the emergency vehicles toward traffic light. Alright, so throughout the whole chapter 1, we can see that to obtain all the objectives and the expected outcome, we have visited our site to collect information at Pekan Bukit Pasir, Johor. Secondly, we have observed the vehicles at 5 to 7 p.m. and the estimated cost was around 30 to 50. So we have choose the microphone sensor. The justification of the sensor will be explained in the upcoming chapters, chapter 3. We have also detected the frequency that is transmitted from the emergency vehicle siren. We proposed our project to the authorities, especially JKR, Jabatan Kerja Raya, and Jabatan Pengangkutan Jalan, JPJ. So why do we choose JKR and JPJ? First and foremost, JKR is to help us to develop the sensor on the traffic light. Secondly, JPJ plays a role in making sure the effectiveness and safety of all road users before and during the work of the sensor. Alright, next, we have also used the software of SolidWorks 2020. This is to design the E-Bus itself, and we also implemented 3D printing digital 3D printing. This is to make sure we can see concretely on how the e-bus is. Alright, here will be shown in a short while. Will be shown example on how the simulation will be played throughout our project. So sit tight and enjoy. As for the software application and the literature review and the methodology will be explained in the upcoming video. That's all from me. Thank you.
Transmits secure data and an optically encoded signal using the infrared emitter. The detector receives the transmitted infrared signal, turns it into an electrical impulse, and sends it to a phase selector located in the traffic control cabinet. The phase selector works with the signal controller's normal operation to cycle to a green light for the oncoming emergency vehicle. Traffic responds naturally. Cross-street traffic stops, and traffic in front of the emergency vehicle clears. The Opticom infrared system is designed to initiate signal changes that seem normal to other traffic at affected intersections, reducing confusion. The infrared emitter is a forward-only transmitter, so the Opticom infrared system does not affect parallel streets. Proper programming of the signal controller timing minimizes disruption to cross-traffic. The goal is smooth, rapid advance of the emergency vehicle through intersections, getting responders to the scene more safely and in the shortest time possible.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Bebrani. My matric number is AA200324. So I will continue of our presentation final year group project. Okay, so I will discuss about the summary of the chapter 2. The conclusion that can we get from this chapter is that there are a variety of smart sensing traffic light detection and application of traffic simulation software that can be utilized to get the best result of this simulation project. It includes RFID sensor, infrared sensor, ultrasonic sensor, and microphone sensor, while software encompass our PTV VSIM 222, ISOMNet 22, SOMO, and Trazim application. All of it comes with a different advantage and disadvantage. Although there are many sensor and software application nowadays, we have considered to and identify the use of a microphone sensor and PTV VSIM 222 after examining a lot of previous research. Okay, why we choose microphone sensor and PTV VSIM as our tool to conduct our project? Because we want to improve the previous research. Okay, moving on to the next slide. Okay, this is a video of a simulation example which is related to our project. Okay, in the video we can see how the microphone sensor working. Okay, as you can see here, when the ambulance turn on the button of the siren, the siren will give a frequency of a frequency or the sound from the siren,
and an optically encoded signal using the infrared emitter.
Okay, the frequency or what we call it the sound will trigger the sensor. After that, sensor we give a sign to a traffic light, and then the traffic light will turn into a green.
The detector receives the transmitted infrared signal,
Okay,
turns it into
red
an electrical impulse,
into
and
the
sends
green
it to a phase selector
after it
located
triggered.
in the traffic control cabinet. The phase selector works with the signal controller's normal operation to cycle to a green light for the oncoming emergency vehicle. Traffic responds naturally. Cross-street traffic stops, and traffic in front of the emergency vehicle clears. The Opticom infrared system.
Okay, moving on to the next slide. Okay, this is software application, which is there are three software which is we use for our final year group project. First is SolidWorks 2002, where we use this software to designing our prototype of eBus device. Okay, so next is PTVBSIM 2022, which is the function is a route traffic simulation software. Next is a simulation of urban mobility, which is SUMO. This software is similar to the PTVBSIM, but this software we just want to compare either the VSIM is good or the SUMO a little bit good. We don't know, but we will compare these two software. Okay, for the design, okay, this is the first look of eBus which is our project. Okay, as you can see, there are 13 parts of eBus. First is a pole, NUC, mount, ball, display screen mount, ball, siren base, siren cover, rotating part, bracket, microphone sensor, and display screen. So all this each part have a dia function. We produce it by using this SolidWorks software. How we get this idea? We get this idea from previous research, but we improve a little bit, maybe for the siren and the sensor, and we also added the display screen to improve the functionality of eBus. So as we mentioned before, this is a software comparison, which is we compare two software of a traffic simulation, which is SUMO and PTVBSIM. As you can see, SUMO is a free, which is open source. You can download free, but the PTVBSIM we must buy it first or apply it before we can use its feature. Okay, what the difference between the SUMO and the VSIM is, the SUMO don't have a two-wheel vehicle, but the VSIM have a two-wheel vehicle, and he also not have a pedestrian, but VSIM have it, and visualization of simulation, which is in SUMO we can see at here online 2D low detail, but VSIM we can see online 2D and 3D and high details. So this is why we choose the PTVBSIM to use of our group final year group project. Okay, this is a sensor justification, which is we compare 4 sensor in order to choose one only, because we wanted to take one only. So first is ultrasonic sensor, second is color sensor, and third is light sensor, and four is microphone sensor. Okay, they have a pro and con of a sensor, which is for ultrasonic is slow detection, color is confused to the traffic light color, light sensor is to detect the amount of light and rise, and microphone sensor is high detection level for sound, which is maybe microphone sensor here Chrome is the weakness when raining situation lah, because microphone sensor will reject with the sound from the rain. Okay, for sensor we choose the microphone sensor because we can see here there have a low of a weakness, so we choose the microphone sensor for our group final year project as the main sensor to to take it into our e-bus device. Okay, that's all from me. We pass to the next presenter. Thank you.
Hi and Assalamualaikum. My name is Tuan Hanif bin Masri. My dormitory is AA200784. To sum up of this chapter is the way we want to achieve for this project. In order to achieve, we have to understand the process from beginning to the final result. To succeed the project, there are several ways that we use, such as research phase, conceptual design phase, detail design, design output, implementing of SolidWorks, CAD, conceptual design of digital fabrication, and also Google Form. To achieve the concept of a design, we use SolidWorks. The chosen design has been truly detailed since it's as sleek as possible while yet giving the highest performance possible. Every aspect of this project is extremely important to our team because it serves as our beginning point. Sensor justification also implemented on this project because we want to see the difference and the capability for this project. Then, for simulation justification, we identify 4 simulations such as Transsim, Sumo, ISOMNEX, and also PTV Sim. At the end, we choose PTV Sim because it's more relevant to our project. Next, we talk about the approach of the e-bus function, where we explain the function and the working system of the e-bus. We also understand the current technology and do some research about the current product, as it is critical since it will be enable our product to meet current market demand and also technology advance. Now we go to engineering field of e-bus simulation of smart sensing for emergency vehicle. There are 3 engineering applications such as mechanical engineering, electrical engineering, and civil engineering. So first and foremost, we go to mechanical engineering, where we apply knowledge of designing by using SolidWorks software. Second is the uses of digital fabrication 3D printer. Third is the using knowledge of manufacturing process to identify the material for the component of e-bus. First is the applying knowledge of basic electric and electronic. Now we go to electrical engineering by implementing different sensors for the functionality of e-bus. Second is justification of the sensor and the realisticness on the real application. Finally, we go to civil engineering, where we studying the knowledge of travel time. Second is creating a complete simulation of e-bus smart sensing using PTV Sim. In order to make our project more relevant, we have identified 7 authorities to purpose the e-bus simulation of smart sensing for emergency vehicle, such as Jabatan Pengangkutan Jalan Raya JPJ, Jabatan Kejar Raya Malaysia JKR, Majlis Pembandaran Muar MPM, Polis Diraja Malaysia PDRM, Jabatan Bomba dan Penyelamat Bomba, Jabatan Pertahanan Awam Malaysia JPAM, and also Kementerian Kesihatan Malaysia KKM. The case study of our project is at Pekan Bukit Pasir Muar. So we have visited this location, and we can see when at the rush hour there is a lot of vehicle that use the road, and when it's come to the emergency vehicle to go through it, there's a lot of messy of here. So we hope by this project of e-bus can help reduce the travel time of the emergency vehicle. Okay, I think that's all from my group. I hope we can understand what we're trying to give to you, and thank you for your time to listen to our presentation.